What's the first thing that you think of that comes onto your mind when you hear the word structures? You may think about of a building. You can even think of a bridge. If you are a computer science student, you will be thinking of data structures. Hello, my name is Prashant, and today I'll be telling you what data structures are. And in the process, we'll even see one data structure. We may take anything. What are data structures? Data structures are basically structures made up of data. That's the most simplest definition I can give you of. But in reality, that's what a data structure is. A structure made up of basically data. Now, if you see any structure, they will be having two things. One is an attribute and one is the property. Attribute means what they have, and property is what you intend to do out of them. There are many data structures like stacks, queues, trees, and each of them does not fit the bill of what you intend to do with them. Let's take an example. Say, for example, what do you call a structure of books? It may easily be called as a library, right? Now, supposedly, you are trying to insert a new book into the library. Now, you cannot keep it at any place. You will be needing a particular place which has been defined by the algorithm defined by the librarian. Why? Because only by using that algorithm, what will happen is the book will be kept at its proper place. And by that, what will happen is if someone asks for that book, if someone wants that book to be issued, you can easily go at that particular place and just take that book and give to that particular person who wants that. So data needs to be so the books or the data, books and data are actually analogous in this particular situation. They they should be kept in an algorithmic fashion. If you're not keeping it in an algorithmic fashion, the searching will be pretty difficult. Why do you store the data? So that you can use it at some time later, after some time, right? So you will be needing that data. Remember of that scenario that you just take a file, okay, and you just keep it at any XYZ place inside your computer. Now the next time when you require that file, and if you don't know that where that file is kept and you haven't followed a particular pattern how to store that particular file, you won't be able to find it. You have to take uh, you have to use the searching mechanism given by your file system. And what will that do? That will be using a brute force approach, looking into each of the folders, each of the file names, just to look that yes, where that file is present. That's the reason you need to follow a particular pattern when you are trying to put a book, okay, so that if you're trying to access the book at some other time, that becomes easier. Why only accessing? Suppose you want to insert something new. Okay, suppose in that library, one new book has come. Okay, and that has to be kept in between two books at some other place because of the algorithm that you are following. Now, what happens is only when you know the algorithm, how the books are being kept, you will say that yes, uh, in between one and three, in between the first and the third book, the second book has to be kept so that the third book has to be shifted by one place forward. So over here, what we are doing an insertion operation. And while we are inserting, it is taking some other place So the book which was at its previous place has to be shifted by one place forward. Okay, I think I am clear on this. Now, this is about insertion. Supposedly, we have got one, two, and three books, and in between that, the second book has to be taken out. Okay, so now what happens? The third book will be taking the place of the second book. So there is a what do we say? A deletion operation which is happening at that particular place. So there are several operations, and based upon the operations, you define your algorithm how you are going to keep your stack of books or stack of data. Now, what will we do is I'll be showing you one particular data structure, which we call it as a stack. What are stacks? Stacks, if you say, for example, you are keeping one book on top of another. Okay, there are like 5, 6 books which are being kept from bottom to the top. Now, what's happening over here is that if you cannot pull down the bottom of the book, obviously you can, but in that case, all the books will fall down. So just imagine that, yes, you're not allowed to let the books fall. You can only access the top of the book, and if you want to access the bottom of the book, at the bottom of the pile of books, you have to remove all the books one by one, just in order to access the bottom of the pile of books. So in this case, what's happening is you have to put the book which is at the bottom first. Then you put the next book. Then you put the next book. Then you put the next book. And this is how you are following it, basically one by one. And if you want to access the books which are down, you have to at first remove the books which are on top of it at first. Then you can access that particular book. Let's jump on to our coding panel where I'll be showing you all these things in action. Let me share my screen at first. Where is that? Where's the share screen option? Where has it gone here? Yeah. Now, let me at first tell you what we are going to do, and then I'll be uh, I'll be writing the code for it, and I'll be trying to make you explain what's happening. Now, you right now have got 2 classes. I hope when we are discussing this, you know what classes are. So we right now need 2 classes. One is one is basically what we can call as a node. Okay, and one we can call it as stack. Okay, what is a stack? What is a node? Okay, node is basically the book. Okay, the book will be having 2 things. One is the value, other one is next. What do you mean by the value and the next? Okay, the book is actually occupying that particular place, right? The book will be having a name, and the book basically knows that, yes, what book is there on top of it. Sorry, what book is there on basically bottom of it. Now, if we come on to stack, stack is nothing but a collection of books. Okay, so we are calling this thing a stack. So there are basically one book on top of the another one. It's basically a collection of books. Now let us define these two classes and then we'll be going forward from there. Let me define, say, stack.js. And over here, first thing we need to do is we need to define a node. So we are defining a node. The node will needs a constructor. The constructor needs a value, and the value has got two things. This dot value is equals to value, and this dot next is equals to null. So that node, which is basically the space where I'm keeping those books, okay? So that knows that, yes, what book is being kept there, number one. And next is, what is the next value? Okay. Now, next thing we need is basically a stack. So let us define a class stack. And inside the stack, we need a constructor. And post the constructor will be having three particular attributes, which are this dot first. We're defining it as null because let me at first write it down, then I'll be describing what they are. This dot last and this dot size. Now, this is the most initial form of stack where it is having no books. So no books means it does not know which book is at the bottom, which book is at the top. And obviously, since there are no books, so the size of that stack is 0. Okay. Now, what operations can you do on stack? You may push the book on top of another. You may put the book in stack terminology. We call it as pushing. So we are pushing things on top of another. So let's push the books on top of one another. The first thing what we'll do is, let's define push. So push is accepting a value. Let me write what push is doing. Okay. It receives the value and puts it on top of the stack. Now, the moment this method is called, what will it require? What are we putting? We are putting a node, right? So the moment we are doing this, what are we supposed to do is we need to define, I'm sorry. We are defining an object of this node class. Now, what will this do? This val will be coming over here. From this constructor method, it will be coming over here, and its value will become the value that I'm trying to pass. So it will be coming here. So its value will be value, and its next will be null. Now, how can we deal with this? So over here, there are two scenarios. When there are no books at all inside that particular stack. And the second case is that when there is already a book inside that stack. Now, we'll be covering those two situations. Now, say suppose the first of it, okay? The first is basically null, the initial case. This will only be true when there are no books in the stack. Now, if this dot first is false, okay, so if this thing is false of this thing is true, so false of null is true, then in that case this dot first is the new node that we have defined. Since this is the first book which has been added, this is also the last book, right? Think logically. So last is new node, okay? And then, yes, then the next case is else. That means if not of null is, I'm sorry, that since this was the initial case, this dot first will be null, right? Now, post it has one book. This dot first is not null, but it is new node. So in that case, what's happening? It's it it has a value associated with it. So not of a value, what will that be? False. So in that case, this case will be coming as false. So my condition will be coming inside of this else block. And then what we need to do is, let's define a temp. This dot first, since we need to swap the value of first. First is basically the top of that node. Okay, so we need to swap this. And for swapping, we are having this temp. Then this dot first is new node, and this dot first dot next is equals to temp. Now, what's happening in this case? See very carefully. I'll just take this whole block of code. Let me paste it again over here itself, so as it will be helping me to make you understand. Now, I think this case is very clear. Okay, when suppose this is my stack and there are no books inside the stack, that means this dot first is basically null, right? There is nothing over here. These are the spaces which I am having. These are spaces. Okay, so when this is null, it's defined in our code. Have a look. When this is the initial case, when this is basically null. In that case, what's happening is this dot null is true. Okay, so the value of this dot first is null, not of null is true, right? So this block will be executing. So this dot first is a new node. This one, new node is nothing but, so this will be the value of this dot first is equals to val, and this dot next is equals to null. So what's happening over here? Null will be removed, okay, and the new node will be sitting here. I will be calling now new node as nn. So this new node will be coming over here. Now, since this is the only book over here, last will also be new node. So both the first and the last are pointing at this new node itself. Now, supposedly, we are trying to insert one more value. In that case, what's happening? We are adding a new pointer over here, which is temp. Okay, then what we are doing? We are pointing this dot first to that new node. Okay, so now this dot first is pointing at new node elsewhere. So now it is this particular step which is keeping it over here. So what's happening? Now this dot first, which is now pointing at this new node is being kept over here now. And this dot first dot next is pointing at this temp. So this dot first is getting removed from here now. And first dot next is putting at this temp, is pointing at this temp. See, we are not touching this last now. So what will happen? At every addition of a new node, okay, only the first will be moving by one step towards the top. It knows where the last is. Okay. And once this thing is done, what are we doing? We are incrementing the value of size, and we are returning it back. So the moment a new node is being added, the size will be incremented and the size will be returned. Now, let's look at one more function, and then what we'll do is we will just we'll test all these functionalities at one go. Now, the next one is pop. Pop means take one value out of the top. So when we are dealing with pop, what's happening is over here also there are two cases. Suppose our whole stack is empty. There are no books inside that stack. So in that case, what are we going to do? So if not of this dot first, in that case, do nothing but return null, right? So if there is no first, say that I cannot pop anything. Now, if you see very carefully, the pop is not having any value inside, right? It's only because it's just a task. Whatever book is there on the top, just remove it. That's it. Now, if this case is not returning null, that means a book is there on the top. So what do we want to do is we take a new pointer and we just point it to the top. Now, it is now this temp pointer itself will try to play down. So if this dot first equals this dot last, in that case, what are we doing is this dot last is equals to null. This is what we are doing. So what are we doing is if the first and the last are pointing at the same pointer, that means there is only one book inserted. That's the second case. So in that case, what are we doing is we are saying that this dot last, which was pointing at the last book inside the whole stack, that will be pointing to null. Okay, and if it's pointing to null, we know that yes, there are no books inside. The next one is the last case when there are more than one books. So this dot first is equals to this dot first dot next. Okay, we are just moving the pointer from the first to the first next, and we are decreasing the size of it, and we are returning temps value so that we know that yes, what's happened. Okay, now let me try to execute this thing and then we'll look at the explanation. Or let's have a look at the explanation first. Now, this is covering three cases. Number one is this, sorry. Number one is this. This is the first case. This is the second case, and this is the third case. Okay. Now, these things are actually happening for all of them. Okay, except for step number one. If I'm going through the second or the third step, okay, these two things are common. This will be happening only for one case where there is only one value at the top. Okay, let's have a look. So if there is nothing inside the stack, that means this dot first is null. Since this dot first is null, not of null is true, so this will be returning null. So in that case, if pop is returning null, that means we know that the stack has got no members inside. Number one. Number two, if this case fails, we know that there is at least one book inside. So what we do is, suppose this has got a book. So if there is only one book, then this dot first and this dot last are pointing at the same book. So what are we doing over here is we are putting one more pointer, temp, and temp is pointing where this first is pointing. Now, if we're just seeing that if the first and the last are pointing at the same pointer, then what we do is we are saying that this last is now pointing to null. We are removing this pointer of last and we are putting it to null. Now, what are we doing? Next, this dot first is this dot first dot next. Now, this first, okay. Now it's time to remove this pointer as well. So what are we doing? We are removing this pointer, and as written inside the code, this dot first, okay. So since now in that case, what will this be? This will be this case. Dot next is mainly null. Now this is how this is becoming, sorry, this is how this is becoming null. Now, since the last book over here has been removed, what we need to do is we need to decrease the size of that stack, which becomes 1 minus minus is basically 0. So the size of the stack becomes 0. And we're just returning what we popped. So temp is still pointing at this particular pointer. We are just returning the value of it. Okay. Now let's try to execute the code. Okay, so we are declaring an object of this class stack. Now, the moment we declare this, this will be having these two attributes assigned to it. Now, next thing, just push something, let's say 1. Let's push a few more values. Stack dot okay. Now we have pushed these 3 values. Now let's try to see what we have inside. So console dot log stack dot first. Let's see where it's pointing. So if you can see what it's pointing to the value 3. And the next is pointing to a new node whose value is 2. Okay. And this next is pointing to a value which is pointing to 1. And once next is pointing to null. Okay. Now let's check for the next thing. Console dot log stack dot size. And let's print one more thing. Console dot log stack dot pop. Okay, it should be giving me the value 3. Okay, now let's try to execute it. So see, the first thing when we are trying to print stack.first, on the top there is a node. Then we are trying to print the size of the stack. Since we have pushed 3 values, we are getting 3 as the output. Now, the next time we are trying to pop, okay, since 3 is on the top, it's getting removed first. Then again pop, we are getting 2. Again pop, we are getting 1. Let's try it one more time. See, we are getting null. And this null is coming from here. Okay, I think, I assume this topic is clear. I could have done it in a bit more better fashion, but yes, I am saving my best for the classes. That's it for the stacks. Thank you.